Alright, so I'm doing number 1 on the POE practice problems, which is a beam with a pin to support at one end. We'll call that joint A roller support at the other end. We'll call that D because we have a couple points in between. That's what's marked on here. So I have an 8,000 pound force coming down right here at point B. I'll call that FB, force at B, which is equal to 8,000 pounds. I have a force right here in the middle that's coming down at an angle, 45-degree angle, which is 4,000 pounds. And I got a force coming down here again, which is 8,000 pounds, and we'll call that point C. I really should have put another point in here. I'll throw this in as E, even though it's in the middle, but I'll go by what the picture says. So, and this is at 45 degrees. Alright, so if all is said and done, all these forces should cancel out and add up to 0 because we got some reaction forces from our supports here. So let's draw in our reaction forces. This is a pinned connection, so we'd have 2. I'm going to assume positive directions upward to the right and see if we're correct later on. This would be RFAY. This would be RFAX. And we'd have 1 over here at the roller connection, RFDY. Alright, so again, all these forces should add up to 0. So once I've put in my support forces, the sum of all those forces in the x direction have to equal 0. They have to add up to 0. So I have, what forces do I have in the x? I have RFAX, and I have a little bit part of the force at C. Force at E, that's at an angle. I'm going to put FE in the x direction equals 0. So how do I find FE in the x direction? Well, I have this angle coming down here, like that, and if it's at a 45 degree, like that, I really want this right here, that component. So if I think of that triangle, that would be the adjacent side to that angle. If I'm thinking adjacent, if this is FEX and that's FE, the cosine of that angle is going to be adjacent, FEX, over the hypotenuse, FE. So FEX is going to equal FE times the cosine of theta. That's the cosine of that angle. I know FE, I know the angle, so I can figure that out. FEX equals, FE is 4,000 pounds. Would be the cosine of 45 degrees. So FEX, that component is, grab my calculator here, cosine of 45 is 0.707. I'll leave that in my calculator, times 4,000 gives me 2828.4. I'll just take one digit past pounds. That's the x component of that force at E. I gotta go back and now plug that in. So RFAX plus 2828.4 pounds has to equal 0. So if I subtract by that much, both sides, minus 2828, do a little algebraic magic here, RFAX equals negative 2,828.4 pounds. Now it came out negative, but that's okay. It just means whatever way I assumed in the beginning that I drew is actually not that direction. So this force is actually going to the left instead of going to the right. So I'm going to leave it as the negative for now. If I redraw it later, I can deal with that, but it would be actually going to the left. So I have my RFAX. That's 1 in the bank. I got 2 more to figure out. So I did the sum of the forces in the x. Now we need to do sum of forces in the y. I'll make this guy switch sides actually. Move over there. So, some of the forces in the y, I'll put that over here, make some room. The forces in the y equals 0. Again, it's not moving. These have to all balance out. So, RFAY, I'll tell you what, let's put this on a new slide, just so I'm going to run out of room already, I can tell. So again, I have the beam, there is 8,000 pounds here, there is 4,000 pounds at a 45-degree angle, 8,000 pounds, and then I have RF dy, I have RF AY, and RF AX, going to the left. Alright, I was doing some of the forces in the y. Gotta be 0. Alright, so I have going up RF AY plus RF dy minus 8,000 pounds, it's going downward, minus the other 8,000 pounds, it's going downward, minus the force at E in the y direction. Now, lucky for us, the force at E in the y direction is actually the same as the x direction, because with 45 degrees, the x component and the y component are the same. So if you go back and do 45 sine of, 4,000 pounds times the sine of 45 degrees, you would get the same amount. So now we have an equation, RF AY plus RF dy minus 16,000 pounds. Actually, we'll transfer all that to the other side. That's 16,000 pounds plus the 2H28.4 pounds. And again, this turns out to be 4,000 times the cosine of 45 degrees. So that would be 16,000 plus 2828.4 equals 1882.4 pounds. And then FEY equals FE sine of 45 degrees. And that's where that came from, just in case you're wondering. Alright, but we have two unknowns in this equation, so we can't go further. We need to set up a moment equation. So I'm going to use my fancy magic to kind of see if I can transfer this to select, kind of copy and paste in this program. Evidently I can't. Alright. So in that case, I need some more room. I'm going to go back to some of the moments. So again, here's my beam. I had 8,000 pounds, 8,000 pounds. I had the 4,000 pounds at an angle, 45-degree angle. I had a force coming out, force coming here, force coming here. RF AY, RF dy, RF AX. Now the distances between here on the diagram give us everything at 3-foot intervals. So this is 3 feet, 3 feet, 3 feet, and 3 feet. Kind of makes things easier for us. So we need to find some of the moments. And I'm going to pick a point. In theory, it does not matter which point you pick. It'll all work out the same. There's some places where the math is a little easier. I'm going to pick point A because it has two forces at point A. So we'll solve for that. Now some of the moments around here, RFAX and RFAY are not going to cause a moment because they're right at it. I'm looking for perpendicular distances in moments, perpendicular distances. So I have this force, which is 3 feet away. I have this force, the components of which are 6 feet away, that far. I have this force, oops, slightly off there, this force, the components of which are 9 feet away. And I have RF dy, which is 12 feet away. So I need to look at those forces and those distances. Now one thing that we didn't look at, this beam does not have a thickness. And in this problem we're not going to deal with the thickness of the beam. So really, the x component of the 4,000 pound force is not going to have a moment, because again it would be pulling sideways, it would be pulling that way. And if we're not going to deal with any thickness of this, we don't have to worry about that. Okay, so what's trying to make it rotate clockwise? I'm trying to set up all my clockwise equal to my counterclockwise. So I have 8,000 pounds times 3 feet, plus I have the y component of the 4,000 pound force, or 2828.4 pounds, and that is 6 feet away. I have another 8,000 pound force at point C, 8,000 pounds, and that is 9 feet away. And finally, that's all my clockwise moments. I have a counterclockwise moment in the reaction force. So I have RF dy, which I don't know what that is, but I do know it is 12 feet away. So now I've got to do some math. 8,000 times 3 gives me 24,000. 2828.4, 2828.4 times 6 gives me 16,970.4 plus 8,000 times 9, 72,000. All that equal to RF dy times 12 feet. So 32,000 plus 16,970.4 plus 24,000 gives me 112,970.4. RF dy times 12, and we divide both sides by that 12 feet. So RF dy is equal to, drumroll please, 9,414.2 pounds. Alright, so I got one of my reaction forces. I got one left. I know this one, we found this one. I need to take what I know from here and jump back. So I'm going to jump back one slide to the y equation that we set up. Now I know RF dy. So that was 9414.2 RF ay. I subtract that from both sides, 9414.2 minus 9414.2 pounds, gives me RF ay is equal to negative 7,531.8 pounds. Probably says that shouldn't be negative. So where did I make a mistake? Ah, and I see it. Right one step earlier, I took 16,000 plus 2,828 plus 2828.4 is 18,828.4. So if I subtract that, let's try this again, minus 9414.2 minus 828.4, should have gotten a negative 9414.2. There we go. That's better. We're all human. Sorry about that. Okay, so now I have RFAX. I got that in the previous slide. I have RFAY. I have RFDY. And I am all set and ready to go.